On our next page, we take a look at quotients with a negative exponent. For example, here's one. We have a quotient, x over y, and the entire quantity is raised to the negative 3 power. Now, we learned earlier that if we have an exponent outside of a parentheses, then we will raise both the numerator to that power and then the denominator to that power. Then we'll use our definition of a negative exponent. X to the negative 3 drops to the denominator and becomes positive 3 exponent. And my y to the negative 3, which is in the denominator, will rise to the numerator and become a positive 3 exponent. So x over y to the negative 3 becomes y to the third over x to the third. So notice that our x and y flip their positions. So, or when we do this, another method to use is if we have a negative exponent, think of that as a flipper. It's going to flip my x over y to become y over x, and my negative 3 becomes positive. Then I bring my 3 into the numerator and the 3 exponent into the denominator, and we get that. So these little rules right here, take the reciprocal, which is what I did, make the exponent positive, and then distribute the exponent. So this refers to that method right there. Actually, either one of them is acceptable. Example 3, simplify using positive exponents. Now you'll know it'll always say that from here on out. We want to always have positive exponents. So here I have my quotient raised to the negative 4. So I will flip it. So now get the reciprocal 3 halves, and it will be raised to the positive 4. Then I will have 3 to the 4th over 2 to the 4th, and that's going to be 81 over 16. X to the third over y to the 4th with a negative 5 exponent. Because of the negative, we will flip it, find the reciprocal, y to the 4th over x to the 3rd, and we'll change our negative 5 to a positive 5. We have a power to a power, which means we're going to multiply and get y to the 20th, and then x to the 3rd raised to the 5th will multiply and get x to the 15th. Then example C, we have the negative exponent outside of our quotient. So to solve it, we will find the reciprocal, b over 3a squared, and we will now raise it to the positive 3 power. Then we will raise each of our products and quotients to the 3rd power, and we'll get b to the 3rd, 3 to the 3rd, and a squared to the 3rd, which is a to the 6th. Power to power will multiply. So that becomes b to the 3rd over 27a to the 6th. So now to understand the rule for zero exponents, we'll look at the situation from 2 different directions. So first, take a look at x to the 3rd over x to the 3rd. So we know that whenever we have a quotient with the same base, we combine the bases by subtraction. So x to the 3, this 3, subtract that 3, and 3 minus 3 is 0. So x to the 3rd divided by x to the 3rd is equal to x to the 0 according to our rule. So now let's look at it from another direction. We know that x to the 3rd expanded is x times x times x. Same thing down here. This x to the 3rd is x times x times x. We cancel, 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 and anything over itself is 1. Thus, we see that x to the 0 power, same situation done a little bit differently, is equal to 1. And that's going to be our rule. You need to memorize it. So I'll put memorize. X to the 0 is equal to 1. So let's look at some examples. 3 to the 0 is equal to 1. AB to the 0 is equal to 1. Negative 5 to the 0 is equal to 1. Oh, but how about this one? Remember that whenever we have a negative, it's the same thing as a product of negative 1 times 5 to the 0. And 5 to the 0 is 1. But we also have this negative 1 times that, and it becomes negative 1. That's something you're going to have to work on right there. That's a hard one to remember. Same thing here. This is 6 times x to the 0. So 6 times 1 is 6. We'll move on to the next video now.